In this video, you are going to learn how to convert an AC signal into a DC signal. First, we will see how to step down a high voltage AC signal to a low voltage AC signal using transformer. After that, we will convert that stepped down signal into a smooth DC signal like 5 volt or 9 volt or any other value that you need for your project. To achieve this, we will use full wave bridge rectifier and I will show you how to implement the entire circuit in Multisim. We will also observe output at each step, so you will clearly understand the whole process. So make sure to watch this video till end because this is going to be very helpful for your electronics project. First, we will make the circuit. For that, we need an AC voltage source. Place it to workspace, and now we need a transformer. For that, go to all groups and search for transformer. And here you find transformer. Place it to workspace. And now we need a diode. For that, select this diode option and search for 1N4007. Here you find 1N4007 diode. Place it to workspace. We need 4 diode. You can also use any other diode you want. And now connect this diode in bridge configuration. And now change the frequency of AC voltage source to 50 Hz. And now connect this AC source to transformer. And connect transformer across diode. And now if you want to check how much voltage is stepped down by the transformer, you can also do this. For that, place a multimeter to workspace and connect it across the transformer. And set multimeter to measure AC voltage. And now run the simulation. As you see, 120 volt is converted to 60 volt. And if you want your AC signal to be stepped down even more, you need to increase the primary to secondary turns ratio of transformer. For that, click on transformer and here you see the primary to secondary turns ratio. Change it to 5 and again run the simulation. As you see, now your stepped down voltage is changed to 24 volt. If you want to step down even more, change it to 10 and again run this simulation. As you see, your step down voltage is now 12 volt, which means AC signal is stepped down 10 times. And now we need one load resistor to observe the output across the diode. Connect this load resistor across the diode and we need an oscilloscope to observe waveform. First we observe the input waveform. For that, connect the oscilloscope across the input terminal and now run the simulation. We need to place one ground. For that, click on power sources and select ground. Place it to the circuit and now run the simulation. As you see, our input is an AC signal. And now we need to observe our output signal. Place another oscilloscope and connect it across the load resistor. And now run the simulation. As you see, our output is pulsating DC. So we need to convert this pulsating DC into smooth DC. For that, we need to add filter, or you can say we need to add an electrolytic capacitor in parallel to resistor. For that, select this option and click on electrolytic capacitor and place it to workspace. And the most important part is to decide what value of capacitor is need to add in your circuit. Like if you add a capacitor of 100 microfarad, then you will not get a smooth DC voltage. Sometimes the capacitor will burst out if you do not use correct value of capacitor. So keep this in your mind while you are doing this on hardware. For the safer side, use 470 microfarad capacitor if you are designing it for 5 volt or 9 volt. So change the value of capacitor to 470 microfarad and again run the simulation. So you see our output is improved, but we need smooth DC. For that we will use voltage regulator, which gives a constant DC voltage. For that, click on power and here you find option for voltage regulator. Search for LM7805. Select this and click on OK. And now we have to disconnect this wire and place this voltage regulator in between them. And now connect one terminal of voltage regulator to capacitor and other to resistor. And connect the middle terminal to ground. And now connect an oscilloscope across the resistor. And now run the simulation. As you see, we have a smooth DC voltage. And if you want to check how much current is flowing through the load resistor, then place a current measurement probe to that wire and again run the simulation. As you see, the current flowing through it is 5 milliampere. If you want to increase the current, then you have to decrease the value of resistor. Like if you change the value of resistor to 500 ohm, then current flowing through it becomes 10 milliampere. Similarly, if you change it to 100 ohm, then current flowing through it will be 50 milliampere. If you want to measure the output voltage, then place a multimeter across the load resistor and run the simulation. As you see, our output voltage is 5 volt. And suppose if you want output voltage to be 9 volt, then you have to replace the 7805 voltage regulator to 7809 voltage regulator. Basically, the last two digits indicate how much voltage it regulates to output. For 7805, the last two digit is 05, so it will regulate 5 volt DC voltage. Similarly, for 7809, it will regulate 9 volt. And let's see what will be the output voltage. As you see, our output voltage is nearly about 9 volt. So in this way, you can design it for different DC voltage. If you found this video informative, smash that subscribe button and like this video.